So welcome to 4Ks Private Tuition. I'm your host Seshungu. In this particular video, we'll talk about electronegativity, which is an important property that we must be able to explain. So let's look at the factors that affect electronegativity and what it is to begin with. So electronegativity measures the tendency of an atom to attract electrons towards itself in a molecule or in a compound. So we are going to see that the value of electronegativity describes its ability, the atom's ability to compete for electrons in a bond. So even in a bond, you're going to have one of the atoms pulling electrons better towards itself than the other. So we call that atom highly electronegative. So you're going to see later on that also bond order, the type of bond, also affects electronegativity. So let's look at the factors that affect electronegativity. To begin with, atomic radius, which is the most obvious one, that if you have a larger radius, you're going to have a smaller electronegativity, radius being the distance from the nucleus to the outer shell electrons. So when this distance is larger, the pulling effect of the nucleus is going to be decreased on outer shell electrons. Okay, let's look at another factor, effective nuclear charge. So looked at this factor in a different video. If you haven't watched that video, you can go and check it out. So this would be the nuclear charge minus the number of shielding electrons. So the larger the effective nuclear charge, the larger your electronegativity, and the smaller it is, the smaller your electronegativity. So you can check out on what exactly is effective nuclear charge in a detailed explanation in a different video. Bond order is important. You're going to realize that you're going to have the highest electronegativity. If you compare those three types of bonds there, you're going to have the highest electronegativity in a triple bond than in single bonds, for example. So that's another factor that will affect the ability of an atom to pull electrons towards itself. How many covalent bonds does it make with the other atom? Okay, oxidation number is exemplified here by our iron. The larger the oxidation number, the larger your electronegativity. So iron 3 plus is going to have a larger electronegativity compared to iron 2 plus, and the least is the neutral ion. Okay, let's move on. Let's look at trends across a period. So electronegativity is going to increase across a period. We saw in a different video that as you move across a period, your nuclear charge is increasing whilst your atomic size is actually decreasing. So this will result in your nucleus having a larger pull on outer shell electrons, which in turn increases your electronegativity. You should remember that across a period, the shielding effect also remains constant. So we can compare here. You see nitrogen versus oxygen. Oxygen is going to have a larger electronegativity because it is a larger nuclear charge compared to nitrogen. Okay, we can also compare down a group. So we see that oxygen is a higher electronegativity than sulfur. These belong to the same group because oxygen is a smaller atomic radius. So as you move down the group, you know that atomic radius increases. So you expect your electronegativity to decrease as you go down a group. So I think this is all you need to know concerning electronegativity. You should also know that the electronegativity of inert gases is 0 on the scale that is used to measure electronegativity. Okay, so I'll see you in another video. Enjoy your study.